Hi everyone, so this is question 10. Somebody wanted me also to solve question 10 for you. So what we're going to do here, I'm going to solve some questions here. I just pray that I finish all of them, but it will depend with time. But otherwise, I'm going to solve some questions here on question 10 because some of the solutions are very long. So I don't know if I'm going to be finishing them, but I'll show you how to solve them quickly and perfectly without making mistakes. Okay, so for these questions, for you to solve these questions, you first have to understand this extension, the extension of binomial. So this extension says if a is equal to 1 in the expansion of this, if a is equal to 1, then the way you expand the binomial will be different from the way you expand the normal binomial expressions. So you say you say 1 plus nx plus n minus 1. This x will increase the power 2 squared over 2 factorial 1, and then n minus 1, like that. It goes on like that. Yeah. Then this is valid when this x here is between -1 and 1, and when x is small compared with 1, then the expansion will be in this form. It will be just like this. And then this also extension occurs, or rather it works when this x here is a fraction, or this power here is a fraction. It works perfectly. So when you're expanding binomial, when you're expanding binomial expansions which have the value of n, which is a fraction, you can use this extension here. So let's see how it's going to help us to solve these equations. So I'll start with the first question here. So the first question is 1 over 1 plus x, and then everything squared. So how am I going to solve this question? First, I'll start by changing this question to this form. It should be in this form for it to work, for this extension to work. I'm supposed to change this question to be in this form. So this is going to be 1 plus x in brackets. So this is just the inverse of that, meaning I'm going to have -2 here instead of +2. So this is what I'm going to expand now. I'll write it here, or let me just bring this equal sign here. So this is what I'm going to expand now. So as we saw here on the extension, the first term is always 1. Since we have our a here, the value of a here is 1. Let me just put here, since a is equal to 1. Yes. So now, since a is equal to 1, my first term here when expanding this is going to be 1, and then I'll write plus here, and then the next one will be n. 1 plus nx plus that. This is the format I'm going to be following. So 1 plus nx. Well, let me first write anyway, we've seen what is this side. I wanted to rewrite the extension here. Now let me just go direct. So this is going to be 1 plus nx. My n here will be -2. So I'm going to put -2 here in brackets. This is my n. And then my x there is the same x. And then I'll write plus n -2 here. Let me show you where I'm So n, I'm on this point now, m, and then n minus 1 over 2, and then x squared. I'll go on like that. Since the question is telling us to reach as far as the term x to the power 3. So this is my first x, and then this is now n, and then n minus 1. So this is just the same as negative 2 minus 1, which is negative 3. I'll write it there. And then my value of x, I'll put it this side, and then this time around it will be squared, and then over this same number that is square, that is the power of x, I'll put it down here as factorial, 2 factorial. So 2 factorial is just the same as 2 times 1, which is just 2, and then I'll write plus there. Again, I'll go on to the next term now, since I've not reached x to the power 3, which is in the question here. This is x to the power 3. Now I'm going to my last term, which is going to have x to the power 3. So my first n will be n, which will be 2 in brackets, and then negative 3. Why negative 3? Because n minus 1 is just the same as negative 2 minus 1, which gives me negative 3, and then the next value of n there will be n minus 2, which is negative 2 minus 2, which will give me negative 4. According to this, I want you to pay particular attention to this. So the first one was n, second one n, n minus 1, third one n, n minus 1, n minus 2, and then x to the power 3 that side. So this is what I'm doing here. And then x, the power of x will now do what? Will increase from x to the power 2 to be now x to the power 3. And I think this is where I'm going to end, since the question says I should end on x to the power 3. And then everything over. This same 3 here, the power of x, it will be 3 factorial. But remember, 3 factorial is nothing but 3 times 2 times 1. So now I think I can simplify my expansion now. So simplifying this expansion, I'm going to have something like this. 1 will come here, and then plus, so negative 2 times x, I'm going to get negative 2x. So I'm going to get negative 2x, and then plus negative 2 times negative 3, I'm going to get negative 6, positive 6, and then positive 6 divided by 2. Or if I don't want to do that, I can cancel these 2 and these 2 there, so that I will remain with negative 1 there, and then I'll say negative 1 times negative 3, and then I'll just get positive 3x squared. And then I'll also multiply this. So if I want, I can cancel this 3 into 3, I'll remain with negative 1 there, and then these 2 can also cancel with that, and then I'll remain with negative 1. When I multiply everything there, I'm going to get negative 4 as my answer. So this is my final answer here. Yes, so this one goes on. So put 3 dots, 1, 2, 3, yeah, to show that it can still be expanded further. And the question also says, so this is the final expansion. Now we also have to answer the last part of the question, which says state in each case the limits of x for which the expansion is valid. So the limits of x for which this expansion is valid, we just get here, just get to this point here, we get this x. So I'm going to get this x, and then I'm going to find the absolute value of this x. So I'm going to say the absolute value of this x is less than 1. So in other words, when you are solving this equation, this equation. In other words, we can say this is just nothing but -1 according to the functions, quadratic functions, or sorry, absolute value functions that you learned last semester. So this is just the same as -1 less x, which is also less 1. This can also be written as -1 comma according to sets, if you remember very well. Now since -1 and 1 are not part of the sets, so I'm going to use these types of brackets. So this is now the full complete solution for question 1 or question 10(1). Question 10I here. So this is the solution for the question. So if you have any queries, you can ask through the email that I'm going to give you at the end of this lesson. So we move on to the next question, which is remember I said I'm not going to answer all the questions due to time, but I will try my best to answer everything if time is going to allow me. So the next question is this is question 2. Is saying 5 over 2 plus x to the power 3. So again, this question having been given us in this form, we also have to convert it in the form that is going to be ideal for this extension to work. So meaning we have to convert it in this form. And how are we going to do that? Let's see. So this question, first of all, we can write it in this form, which is going to be like this: 2 plus x to the power 3. But remember, this time around, this thing is supposed to be negative. And then from there, we can also write this question. Remember, on this part here, the value of a is supposed to be 1. This extension only works when the value of a is equal to 1. But when you look at here, the value of a is 2. So how are we going to change this? So we're going to say, okay, I will write it here. This equals there. And then we're going to say 5. This 5, I'll write it outside. And then I'll open these square brackets. And then what you do is you divide these numbers inside here by 2. When I divide 2 by 2, I'm going to have what? 1. Actually, I'm going to divide everything by 2 there. Or rather, let me not say dividing by 2, but let me use the word factoring out 2. So how am I going to factor out 2? I'll write the 2 there, and then I'll open the brackets. And then when I factor out the 2, it's just the same as dividing this 2 by 2. When I divide 2 by 2, I'm going to get 1. And then when I divide x by 2, I'm going to get x over 2. Pay particular attention here. These are some of the questions that the lecturers like bringing in exams. So what I've done is just nothing actually. I've just factored out 2, and I'll put this -3 outside there. So this, when I multiply this 2 times 1, I'm going to get 2. When I multiply this 2 times x over 2, I'm going to get what? X. So I've just removed these 2 outside the brackets. So this expression can also be written as what? As 5 outside. Remember the rules of indices. This -3 is not only on this function in the brackets, but also it's also the power of 2. So I'm going to write 2 to the power negative 3, 2 to the power negative 3, open brackets, 1 plus x over 2 to the power negative 3. Hope we are all following, because this is very simple. Yes, so 2 to the power negative 3, I'm sure you can agree with me to say 2 to the power negative 3 is nothing but, or let me first write this 5 here, 5, and then I'll open the same curly brackets. Then 2 to the power negative 3 is just nothing but 8 to the power negative 1 to the power negative 1, and then I'll open brackets 1, I'll write everything the way they are, x over 2 close brackets, then to the power negative 3, like that. But I'm sure you all know to say this 8 to the power negative 1 is just the same as 1 over 8, open brackets, 1 plus x over 2. Yes, like that. Yes. Hope we are able to see what is being written here. So this is how simple it is. We move on to the next step. So we all know that this 5 can multiply with that, right? Yes, we can multiply, we can open the brackets now. So we're going to have something like this. 5. So 5 times 1 over 8 is just nothing but 5 over 8. And then 5 over 8, open brackets. Then this is going to give us 1 plus, I'm just rewriting what is in the brackets there, 1 plus x over 2, open, close brackets, to the power negative 3. Yeah. So this is what we're going to expand here. So this is what we're going to expand. So in expanding this, I'm just going to expand this, and then at the end I'll multiply it with 5 over 8. So in short, what I'm trying to say is this. I'll write 5 over 8 outside there. I'll write 5 over 8 outside there, and then I'll write these types of brackets, the curly brackets. Okay. Let me write it properly. Somebody might think it's a set. Alright, it's now okay like this. So from there, I'm going to expand this. So remember, I'm going to use the same extension because my expression here now in the brackets is in the form of this extension, 1 plus x to the power n. I can now use the extension to expand this. So this 5 over 8 is here, and then the extension is what I'm going to use to expand that. So the first term in the extension is always 1. The second term we all know to say is always n. So according to my expression here, my n is negative 3, and then x, my value of x there is x over 2. Okay, and then I'll write it like that, and then I move on to the next term. The next term here, my value of n is negative 3, close brackets, and then followed by n minus 1. So what is my n minus 1 according to this n, and then n minus 1, and then what is my n minus 1 there? So my n minus 1 is just nothing but negative 3 minus 1, which is negative 4. And then I'll close brackets. And then x I'll write this x over 2. I'll put them in brackets. This is my x now this time. To the power what? To the power 2. This was to the power 1, but this now to the power 2. Don't forget to put this 2 factorial down. 2 factorial. And then the last term here, which is going to have x to the power 3, is I will write my n there. What is my n? N is negative 3. And then my n minus 1 is negative 4. And then my n minus 2 is negative 5. Okay, n minus 2 is just the same as negative 3 minus 2, which gives negative 5. So from there, I'll write x to the power, x over 2 to the power what? To the power 3. And then everything over 3 factorial. Remember, 3 factorial is just the same as. So this is the answer that we're going to get as your final answer. And then remember, the question is also telling us to find to state the limits for which x for which this x is going to be valid. So to get the limits for which this x is going to be valid, you come back to this expansion that you are expanding here, x over 2. So this one 5 over 8, 1 plus x over 2. So this one you only get this part. You only get this part. So this part is what we're going to get, and say the absolute of x, the absolute of x over 2 is less than, so the absolute of x over 2 is less than 1. So when you get this, according to what you learned last semester, the absolute values, you can also relate it to say this is just the same as x, absolute of x less than 2. The final answer will now be, remember what we did at first when we had 1 this side. So this is just going to be negative 2. So negative 2 less than x less than the positive of 2. What is this now? Less than the positive of 2. So this can also be written in set notation as negative 2, then comma 2. This is in set notation. Then you close the brackets like that. So we continue with question 4. So question 3, of course, you have to go and research. You just do the same way I did the previous question. So move to question 4. Question 4 looks a little bit different. So question 4, the root of, this is just the root of 3 plus 2x, the root of 3 plus 2x. So this question also, we need to use the same method that I used, which is the extension of binomial. This is the one here, and if this is our question, it implies that we have to start, or we have to find means by which we are going to make that question in this form. And how are we going to go about that? How are we going to do this? So we're going to, we all know to say this is nothing but the same as 3 plus 2x This is just the same as 3 plus 2x, then in brackets to the power half. We all know this. So from there, you can also do the way we did this question, where we said you open the big brackets there, like that, and then you write 3, you factor out 3 there. So we can factor out 3, we can factor out 3 like that. So when we factor out 3, it's just the same as dividing everything here by 3. So we divide 3 by 3 there, you get 1, and then 2 divided by 3, you get 2x divided by 3, you get 2x over 3. So this should be in such a way that if I want to go back to this, I should just multiply 3 times 1, I'll get 3, and then 3 times 2 over 3x, I'll get 2x, like that. So if you get a different answer, just know to say you've made a mistake somewhere. So this is raised to the power half. Yes, like that. So according to the laws of indices, we know that that is nothing but equal to 3. We can distribute the power there, 3 to the power half. Then you open brackets, 1 plus, this is 2x over 3. So like that, and then to the power half. So this is now easier to expand. So you can expand it using the same extension here. So you can expand it according to this question. The value of n there is half, and then the value of x in our expansion is 2x over 3. So meaning you expand everything there the way we did the previous questions. Let me just help you to find the limits of which x is valid. So to find the limit, so you expand this. This is straightforward. Let me also move a step further, maybe to simplify things when expanding. So when you're expanding now here, before you even start expanding, you know that 3 to the power half is nothing but the root of 3. So you expand. So this is what you're going to expand. I've simplified it for you. You can expand it, it's very simple. Yes, so this is what we're going to expand. So now let me help you now to find the values for which x is going to be valid for this expansion. So you remember what I said, you just get this part here. You write this part, 2x over 3, you put it in absolute values brackets like that. You say it's less than 1. So what you do here, you cross multiply, though there is no cross multiplying when you have a less or greater sign here, but I'll just say that for the sake of simplification. So you cross multiply 3 times 1 there, and then you divide by 2 there. So meaning you're going to remain with something like this. The absolute of x is less than 3 over 2. So when you have something like this, you can now say the answer will be negative 3. So the values of x for which the expansion is valid is negative 3 over 2 less x, which is less, which is less 3 over 2. As simple as that. If you want, you can write it in set notation, which is just the same as negative 3 over 2, and then comma 3 over 2. So these are the values of x for which the expansion is valid. So this is how you do even the remaining questions. They are not that difficult. Looking at this question here, question 5 is just the same as question 2. The difference is not that much. The only difference there is that this one has the power 3, but this one has the power half, because the square root of any given number is just the same as the power, it's just the same as raising that number to the power half. So this one has the power 3, this one has the power half, which is just the same. Let me show you what I'm trying to say here. The question is the question is 5 over 5 plus x. The question is 5. This is question 5. 5 over the root of 5 plus x. So the only difference between this question and question 2 is that question 2 is the denominator is raised to the power 3, but for this question the denominator is raised to the power half. So this one can also be written as what? 5 plus x, like that, x to the power negative half. So this is the only difference. Oh, sorry, not negative, it's supposed to be positive half. Yes, and then when it goes up, that's when it will be negative, like that. So it will be 5, and then open brackets, 5 plus x, so 5 plus x to the power, this will now be negative half. To be negative half. So this is the way it is. Then from there you can change it now to the form where the value of a here becomes 1. You change this 5 into 1, you change it into this form. It's supposed to look like this. So I want you to try to change it. Let me just write the final answer here. The final answer after changing this into that form is 5 over root 5 is 5 over the root of 5. Then you open brackets, 5 over the root of 5, you open brackets, 1 plus x over 5 plus x over 5. So 1 plus x over 5, and then you close the brackets like that, to the power half. Negative, of course. And when you rationalize this, you discover that you just have root 5 outside. So you just have root 5 outside, and then you repeat everything like that. You repeat everything like that. So that is how it's going to look like. So this is what you are going to expand here. You expand this then you at the end, after the expansion, you come and multiply it with the root of 5. Come and multiply your expansion with the root of 5. And then I want you also to find the terms in which the terms for which the expansion, the terms for the values of x for which the expansion is valid. But let me write them here as your answer. This is what you're going to find. But try to find it somewhere. I'm writing this answer so that you just come and confirm after finding your values. X and then less 5. So these are the answers for question 5. So after expanding that, you find the values of x for which the expansion is valid. These are the values here. Alright, shalom shalom. Let's move on to the next question, the last question. I'll also just explain briefly how to answer the last question, because it's also very simple. It's also very simple. Let me just do this. Okay, it's also very simple. The last question is saying the square root of that. So let me just answer it from this side. So the last question here saying the square root of 1 minus x over 1 plus x, also notice 1 plus x. So this is how the last question is. So in the same way, you change this form, you change this question to this form. And how are you going to do that? Simple. So what you do is, you know that this can also be written as sorry for that, the computer started performing. That's why I'm even doing it very quickly. Mine shut down anytime soon. So this can also be written as 1 minus x everything over the square root of 1 plus x. So after that, you can now do it. You can now change it to the form that is favorable, or that is ideal to be expanded using the extension. So this can be written as the square root of 1 minus x, and this question is very much straightforward. You multiply it with the square root of 1 plus x, like that. This one will be to the power negative 1. So this one can also be written as what? This one can also be written as this 1 plus x, oh sorry, 1 minus x to the power negative half, oh sorry, to the power half, then multiplied by 1 plus 1 plus x to the power negative half, like that. So from this point, I think everyone can take it up. It's now simple. you just have to expand this separately up to the term x to the power 3. You also expand this separately. Then after all the expansions, you quickly do what? You quickly multiply them. You quickly multiply them, and when you're multiplying them, make sure that you just get the powers of x, the terms that have x and the terms that have x squared, and the constant terms and the terms that have x to the power 3. Then you add them. Then after adding them, that's your final answer. That's your final answer. Yeah, so it's as simple as that. You expand them, you multiply them. Yes, you expand them, you multiply them. Then after multiplying them, you find the final answer, that is up to x to the power 3. And then you find the values of x for which this is the expansion of this is valid, and the values of x for which the expansion of this is valid. So this is going to be your final answer. Thank you very much for watching. Don't forget to subscribe to the channel. Make sure that you subscribe so that you don't miss out the videos that are going to be posted in the next coming lessons that we're going to be having. Thank you very much for watching. Subscribe now.